Hello and welcome to ETG 4950. In this session, we will address some of the methods and techniques used to prepare the quantitative data and find its parameters. The collected data through questionnaires and interviews should be cleaned and accuracy should be verified. Once the data being cleaned and verified, the descriptive statistics can be provided. To prepare the data for analysis, we need to check data accuracy, then transform data to the proper format, then develop a structure to be able to analyze, store, and retrieve data when needed. The data collected from a paper survey can be in different forms and at different times. The first step is to enter the data the way that it was received, which is called raw data. If the data was collected through a computerized system, then it can be categorized and refined during entering the information by the user. The computerized option depends on the technical literacy of the population to be surveyed. The received data should be checked for accuracy. For example, an entry of surveyed person age was 250 years old instead of 25 years old. So something like that, a mistake like that, it's obvious that there is no one with the age of 250. Actually, you can make the system recognize it automatically and then either verify with the user or make the adjustment as needed. Those data points will be either corrected or you can send the question back to the user. Some paper surveys will have incomplete address. If they are writing the information on paper, they might have the address incomplete or the words are unreadable, which should be either verified with the user or retaken through other methods. When the data is sent to analysis, blank spaces in the survey will be automatically treated as missing values. You can use average, median, or mode of the collected information to replace missing data, but that depends on the type of data and information you will be collecting. During the transformation, data will be sorted to send the data to the right repository. The data will be stored in a structured relational database or unstructured documentation database. The purpose is to store the collected data to be easy to analyze, manipulate, and generate new reports. Databases can be managed using database management systems that will increase the flexibility of manipulating the data. To describe the basic features of the data in study, we use descriptive statistics. With descriptive statistics, you are simply describing the population needs and wants. The summaries could be depicted through numbers, graphs, and charts, which will show trends, requirements, and features. Some of the measures that could be used: the mean, which is the arithmetic average. I'm sure you know how to get that or calculate that for a group of data points. The median, which is the value in the middle of the collected data points. And the mode, which is the value observed most often in the data points. Each of these measures is legitimately referred to as an average. Some people will call the median average the mode average, so you don't know which one is the average. Accordingly, you need to confirm with the analysis team which do they refer to as the average. To calculate the mean, we use the following formula: x bar, which is in this case the average, so we refer the bar here refers to the average. will equal to the summation of the data points, which is xi, where I goes from 1 to n, divided by n, the number of data points in a sample. And notice that this is a lowercase n. This average is calculated for the sample. When it's lowercase n, it's calculated for the sample. While for the population, the whole population, the average is called mu instead of x bar, and mu is the Greek letter for m, which will equal to the summation of xi, where I goes from 1 to capital N divided by capital N, the number of data points in the targeted population, the whole population. For example, the following are the ages of the 7 employees of a small company. So in this case, the population, the whole population is the 7 people in the small company. Accordingly, we can calculate the average for the whole population, which is mu. The data points that we have, the 53, 32, 61, 57, 39, 44, and 57. Adding all those together, the summation will be 343. Divide by the number of data points, which is in this case 7 data points, will equal to 49 years. So the average for these numbers is 49 years of age. To calculate the sample median, first we put the data points in order from the lowest to the highest. The median will be the data point x of n plus 1 divided by 2 if n is odd number, while the median m will equal to the sum of the data points x of n divided by 2 and x of n divided by 2 plus 1 all divided by 2 data points. For example, the following are the ages of 7 customers who purchased the new product. So consider those ages for customers purchase the product. What will be the median in this case? First, we need to rearrange the data points or sort them from small to large. So you can see that we started with the 32, ended up with the 61, and then the median will be the x of 7 plus 1 divided by 2. 7 plus 1 is 8, divided by 2 is 4. So basically we are saying the median is the 4th data point, the 4th data point in the collection of data. In this case, it's 53 years old. So the median for the population is 53 years old. In the same example, let's calculate the mode. And the mode is the number of observations that's been repeated more than one time, the most one that's been repeated. And in this case, we have 57 being repeated twice, so 57 is the mode for this population or these data points. Another example, if we have 29 years old who joined and reviewed the product and bought or purchased the product, recalculate the mean, the median, and the mode for the data points, those data points. So take your time and calculate those and make sure that you can measure the mean, the median, and the mode for the population. And again, if you have any questions for that, just let me know and or email me and I will explain it for you. Almost always when an average is reported, it's the mean. Medians are useful when extreme values, whether it's high or low or both, would have a pronounced effect on the mean. For example, average housing prices and incomes are often reported in terms of median values, because in certain area you will see extreme highs of income and extreme low of income So those will affect or will impact the data points. That's why usually we take the median in this case. For the mode, it's used infrequently for quantitative data. Usually it's good descriptive measure for qualitative data. Another measure that we are interested in is the variability of the data, which can be represented in different forms. It can be represented through range, variance, standard deviation, and coefficient of variation. The range is the difference between the largest and the smallest value in the data points, while the variance is the mean of the squared difference between the observations and their mean, which is equal to the summation from 1 to n of the difference between the data points and the average, all squared divided by n minus 1. We can also use another form or formula to calculate the variance. In this case, the variance will be equal to n multiplied by the summation of the square of each data point minus the square of the summation of these data points, where the summation is from 1 to n, and all this is divided by n multiplied by n minus 1. The standard deviation is the square root of the variance expressed in the same units as the mean. So basically, let's calculate the standard, calculate the variance first, and then take the square root of that, and that will be the standard deviation. The coefficient of variation is the standard deviation divided by the mean, and that's a measure of relative variation. So we divide the standard deviation by the mean and then multiply by 100%. Based on the definitions and the provided formulas, give the data in this example a try to calculate the average, the range, the deviation of the price, the variance, the standard deviation, and the coefficient of variation. So try and see if you can solve this example. Statistical measures cannot be more accurate. Which means that we cannot have more digits than the data themselves. Additional digits don't lead to additional precision. So as a suggestion, for intermediate calculations with data, retain data accuracy as much as possible, and for final answers, include one extra significant digit if needed. Inferential statistics investigate questions, models, and hypotheses. In many cases, the conclusions from inferential statistics extend beyond the immediate data alone. For instance, we use inferential statistics to try to infer from the sample data what the population thinks. Or we use inferential statistics to make judgments of the probability that an observed difference between groups is a dependable one, or one that might have happened by chance in this study. Basically, we use inferential statistics to make inferences, more than one, from our data to more general conditions, while we use descriptive statistics simply to describe what's going on in our data. So the descriptive statistics will tell me about the population and what they have, their average, their standard deviation, their variance, the median, the mode. Those are the things that I'm learning from descriptive statistics. But for inferential statistics, it will tell me more about the population, and I can create hypotheses and then either verify them or deny them. And based on that, I can adjust my design, my product design to match the requirements or the needs of customers. And this is the whole idea, is to understand the customer, know what they need, know what they want, and based on that, add the features, the specifications in our product to match those requirements or those needs. You can use many tools and techniques to analyze the quantitative data and understand customer needs. Then you can translate them into design specifications that will be in the product, or that will be given to the customer at the end of the production period. So again, you don't have to use these statistical tools that we talked about. You can use software, other software packages. You can use any other technique or any other tool to understand what customer needs. That will be all for this session. If you have any questions, please let me know. Thank you and have a great day.